Alright class, today we're going to do more law of sines. Real quick, we're just going to kind of review what we did yesterday. So pause the screen to write all this down. Alright, and then now we're going to start. We know this is law of sines because we have an angle and a side for A. So the first thing we have to do is find angle C because that's the thing that's missing and we have the side for it. So we'd say sine of 51 over 40 equals sine of C over 50. Now remember, when you're looking for C, or an angle, you're going to have to use sine inverse, and you want to move the 50 over first. So it becomes 50, actually it's going to become sine inverse of 50 sine of 51 over 40. So when you type that in, just make sure your calculator is in degree mode, so you don't make that mistake that other people have done. And you get 76.27 degrees. So I put that there. That makes sense, but remember we could also check the supplement. So over here we have to check 180 minus 76.27. And then when you get that, you get 103.73. So I'm going to put that there. And sure enough, that angle works with 51 as well. Which means that we do have two triangles, so we just have to finish up, find angle B on both of them. So angle B is just 180 minus these two. And over here, angle B is going to be 180 minus these two. Okay, so you just type those in. The first one's 52.73. The other one is 25.27. And now that we have angle B, we can find side B by using law of sines twice. So I'd say sine of 51 over 40 equals sine of B, which is 52.73 over B. Now again, you move the B over here with the sine of 51, the 40 goes with the sine of 52.73, and then you basically multiply those together and divide by sine of 51, and you get that B is equal to 40.96, which makes sense because it's a little bit more than the 52.7, or than the 40, because the angle's a little bit more. Over here you do the same setup. And cross multiply. Actually, well, there's a problem with the same setup here. It shouldn't be the same exact angle though. Angle B is slightly different here. It's 25.27. So you're going to do 40 times 20, the sine of 25.27, and then divide by the sine of 51. And here you should have a smaller number because the angle is smaller than 51, and sure enough you get that B is 21.97. 21.97. Alright, so that is that problem. It was a double triangle problem. Now we're going to do an application. So we have a hot air balloon is seen over Park City, Utah, simultaneously by two observers at points A and B that are 2.32 miles apart. Assume that the balloon and the observers are in the same plane, and the angles of elevation and the distances are as shown in the figures. First thing we need to find is what is the distance from observer A to the bottom of the balloon. So we're looking for this side first. Well, we have angle 38 across from that. We need another angle and side pair. Well, the only side we have here is that. We need this angle as well. Luckily, we have two angles in the triangle. So first thing you need to find is that angle, we'll call this C up here. So angle C is 180 minus the 28 minus the 38. Alright, that's the first thing we have to find. So we get, sorry, I got a negative number, that's not good. 114. So now I know that this angle is 114. Now I can do law of sines because I have the angle across from the side. I want this side across from this angle. So, and since this was an angle-angle problem, this will not be a two-triangle problem. We only have to work with the one. So I would say sine of 114 over the 2.32 is equal to the sine of 38 over x. Technically I probably should have written B, but I put X on the diagram. So again, you multiply the X over, multiply that over, so it's going to be 2.32 times the sine of 38, and then divide that by the sine of 114. And you get that X is equal to 1.56 miles, because we're in miles. So that's the answer to part A. Then it says, what is the height of the balloon? Now whenever you hear the word height, you have to think a perpendicular line from the balloon down to the ground. So now I'm making a right triangle. So this is kind of a review from before. The problem with this is you cannot assume that this thing splits it in half because the angles are different at the corners. It's kind of tilted. But what we can do is we can use SOHCAHTOA with the stuff we just found. Since we found this length here, I'm going to use this triangle here. So I'm going to redraw that triangle, just this side of the big triangle. I don't know where this split, so I can't write any numbers on the bottom. I do know that this is 28 degrees, and now I know that this is 1.56, and I want to find the height. So now that we found one of the hypotenuses of the right triangle, we can use SOHCAHTOA here. Since I have or need opposite and have the hypotenuse, I'll just say the sine of 28 equals h over 1.56. So when you multiply 1.56 times the sine of 28, we should get the height of the balloon. And the height of the balloon is 0.73 miles above ground. Okay, so there are problems where you have to do both things. You have to use law of sines to get a piece and use it to get whatever you can, and then if you draw in a right triangle, you should have enough pieces to find the height. That's it for today. I'll see you guys next time.